Daniel Faber is a serial entrepreneur and pioneer in materials, entertainment, and mining technologies in space. Mr. Faber has grown several high-tech companies from startup through commercial success. He is the recipient of multiple innovation awards and has filed a number of patents in the fields of mining, entertainment, medical imaging, and aerospace. Mr. Faber is in the process of completing a double MBA at UCLA Anderson and National University, Singapore. He holds a degree in engineering from the University of South Wales and a postgraduate certificate in Antarctic studies from the University of Canterbury. He is currently the CEO of Orbit Fab, which is launching the world's first gas station, trademarked, tanker next year with spaceflight. This first propellant depot will store propellant in sun-synchronous orbit, where it will be available to satellite servicing vehicles and other spacecrafts that need to replenish fuel supplies. Fascinating and essential to developing space infrastructure. Please, Daniel Faber.
Thanks very much, Leila. Let me try and share a screen here. Let's see, are we working? Excellent. So let's talk a little bit about space. It's big, and at the moment, if my slides work, it's not very bustling. There's some debris and things move quickly, but in terms of objects and equipment actually interacting, that doesn't happen. In the entire history of the space industry, what are we now, 60, 70 years, the commercial industry, 40 or 50 years, there's been one instance of commercial satellites docking together in orbit. And that was just just earlier this year with Northrop Grumman's first mission extension vehicle. That is not a bustling space economy. Well, that's something that we want to change. Our vision at Orbit Fab is that bustling space economy where goods and services are being exchanged, equipment is interacting in space on not a once per 50-year basis, not even a daily basis, but an hourly basis or more common than that. We want to make that an every day and every hour happenstance. And so that was something that we were passionate about. We started looking around at the industry and realized that we do have a space economy. We build things on the ground and we launch them into orbit. What we don't have is an economy in space, but there are a lot of investments going on, and the kind of things you've heard this morning from Rob Hoyt, from Nagar, about how spacecraft are going to start doing assembly in orbit and distribution, connecting flights. These are critical parts of building that. Reusable rocket launches, all of these kinds of things are working towards a bustling in space economy. But here's some examples of what happens when you get there and you use just one tank of fuel. We lose about $10 billion worth of value of satellites every year because they run out of fuel, not because the electronics go bad or because they're no longer useless because they're old, but because they run out of fuel. In these examples, Express AM4, actually at one of my past companies, we tried to buy this satellite. It's a telecommunications satellite, cost about $300 million to build and launch. Should have brought in a few $1 billion of revenue, but it had to be thrown away because there was a glitch in the rocket and it couldn't get to geostationary orbit where it was intended to operate. And because they couldn't get more fuel to it, they couldn't get it there, they burned it up in the atmosphere to avoid it becoming debris. Just a complete loss. And that's not isolated. This happens just all the time in the industry, surprisingly often, considering how expensive these assets are. Galileo 5 and 6, the European version of GPS satellites, they had the same problem, couldn't reach their operational orbits because no one could get more fuel to them. That delayed the introduction of, I think, a $12 billion constellation for the European GPS system. And of course, if you look at Starliner, just a year or so ago, it was launched, got to orbit, but couldn't reach the space station because they had some software glitches. They ended up with not enough fuel. And now, basically, they're getting their lunch eaten by SpaceX. How much is that worth to a company like Boeing that they weren't able to bring that to station? And then we have the space debris issues where we do have a lot of buildup of space debris, and we don't have a good way to remove this debris. There's no garbage collection service. And the reason is it takes so much fuel to get up to a piece of debris, grab it, bring it down to the atmosphere where it will burn up, or take it to a safe disposal orbit, and then go and get another piece. We need garbage collection trucks in space. We need tow trucks in space. We need to be able to recover these systems so that we're not just throwing away these billions of dollars of value. But the paradigm at the moment, if you look at similar assets on the ground, 15-year lifetime for a car or a plane, we refuel these daily or weekly. We're even refueling rockets now 5 times or 6 times now for the SpaceX rocket. I think the suborbital rockets at Blue Origin are over a dozen times. But satellites, no refills. We just don't refuel these. That's a very inefficient paradigm. But there is a revolution happening. We've heard from Tethers, we've heard from Momentous. Just this year, Northrop Grumman successfully started operating the world's first tow truck in space. They operated the mission extension vehicle. They attached to an Intelsat satellite. It's been published that Intelsat is paying them $13 million a year to act as a jetpack, taking over the thruster functions because their satellite has run out of fuel. Now, that's going well. They've actually launched the second one. It's slowly made its way to geostationary orbit, and it will be doing a docking in geostationary orbit. They're not even taking that next satellite out of operation. They leave it there in the orbit. So this is fantastic progress. So there are now 2 tow trucks operating in space, but there are lots of different business models. And so Nagar also brought up this Northern Sky Research report and the sort of amounts of dollar values and different applications that it talks about for satellite servicing. This is what we've seen in the ecosystem. When we formed the company in 2018, there were 8 or 9 tow truck companies, satellite servicing companies. There are now 45 companies. That is a 500% increase in under 3 years. That is a sign that there's some value to be created here in a capital intensive market when so many new entrants are getting into this field. We look at this, and what shocked us the most was that every single one of these tow trucks relies on a single tank of fuel, and then they throw away the tow truck after it's towed 1, 2, or 3 customers. That was amazing. Our job then, our mission, is to provide that ubiquitous supply of propellant in space. We are creating gas stations, basically. We want to distribute a network of gas stations so that in your satellite's local suburb, there is some gas you can get. And the first people that we want to sell this to are the tow trucks. They're equipped to handle legacy satellites. They're equipped to distribute satellites to different orbits. They're equipped to do inspection. They're equipped to do all of those business models. And they're not afraid to do proximity operations and docking. That's something that's already a part of their business model. And so for us, that's a natural step. We can then save them from having to replace those tow trucks every time they run out of fuel. That's our business. So we build tanks, we put them into orbit, and on any available launch vehicle, so we get the best deals that we can. When they're in orbit, we manage the logistics, the orbit mechanics. We make sure we have the right fuel in the right place. And our customers then, they come to our tankers and to our depots in order to get fuel. And then they can go and continue generating revenue, increase asset utilization, have more flexibility in their business models, go after new markets they didn't imagine before. So this seems very simple in theory. However, when we tried to build the first tanker, we failed completely. We failed miserably because we couldn't buy a fueling port to transfer fuel between 2 satellites. It didn't exist. There was nothing commercially available. So we've become a gas cap company. We're building satellite gas caps. That's what we started out as our first product. We talked to dozens of companies. We talked to a number of government agencies about what they would like to see. And then we ignored some of what they said. We took a lot of what they said to heart, and we decided we would need a system that could work for most use cases, for most of the customers, that would be an absolutely robust and solid solution. And this is what we've come up with. This is what we call the RAFT, the rapidly attachable fluid transfer interface, which combines both a grapple system and the fueling ports. So we've been going through the flight testing for this. The US Air Force got interested in a funding qualification to their standards. We've sold to commercial customers. I think we're exporting to Japan, Europe, UK, of course, North America. So we're getting quite a bit of traction with this system. Here's a little video of how one of the prototypes works. As you can see, the fingers grab and away you go. That's strong enough to be able to hold the force of two multi-ton satellites held together and transferring high-pressure propellants, both things like hydrazine and water for momentous, or xenon for the electric propulsion systems. So that's the fueling port. We then tried again to build our first tanker, and I'll admit we failed the second time. This time because we couldn't find a specification for how to dock two satellites together. For love nor money could we find a spec on camera resolutions or fiducials or LiDAR or intersatellite communication. There was nothing published, especially for cooperative docking, which is the ecosystem that we want to evolve. There's a lot of work that's been done by the tow trucks on docking with unprepared spacecraft or non-cooperative spacecraft that weren't designed to be docked with. The future that we want to see come to pass is a completely cooperative ecosystem where the tow trucks are still needed whenever anything goes wrong. But most satellites have that capability to be maintained, serviced, upgraded, moved to different orbits and those types of things. So we started working on this. How do we develop a self-driving satellite kit? And we got some funding from the National Science Foundation, a nod to them, and have built, you can see, an air-bearing table where these little things float around and they act with the dynamics with real physics, so you can see how the interaction happens. And so we've put our fueling ports with that grapple feature onto this air-bearing table with the algorithms and the sensors, and we started to do tests and things. So once we had this in hand, we circled back again, and we're finally able to get some flight experience. So one of the other things that we need in this, of course, is feed systems, pumps and tanks and the like. What you can see on the left here is an inflatable tank that we developed, where part of our future ecosystem is that you can launch a satellite without any fuel. In fact, even better, you can launch it with a tank that is stowed, so you don't have to carry a big empty tank. You carry much less volume. So this folds up to fit in about a 2-unit CubeSat volume, and then expands to have about 12 liters of capacity. And so we built that, we tested it, we flight qualified it, and that was launched along with a rigid tank full of, in this case, water. And that was tested on the International Space Station. So we did a couple of launches to the space station and looked at the residual momentum and the dynamics and that expanding tank, the propellant feed systems to be able to move that back and forth. And so we used, sort of exercised all of those systems and made sure that would work. And then we hooked it up to the water supply on the International Space Station. We became the first private company to resupply the space station with water. Now, I can't understate how little technical knowledge we gained from this, but how important that was from a business and process perspective. Because NASA has a very set way that it buys water. They buy it on the ground, and then they buy a launch, and they put the two together, and that's how you get water to the International Space Station. We showed up and said, we bought the right connector. Here's our tank. And I'll admit it blew the minds of some of the NASA folks because they'd never thought that they could do that before. But it also opened the possibility for alternative supply chains. If we can manage to find some way to get this to orbit that doesn't require a man-rated vehicle and all these other things, but still we're able to enter that supply chain at a literally a higher point in the supply chain, now they've got their heads wrapped around how to do that. So that was super important for us to be able to get through this. And it's worth noting one of the fun aspects of this project, we were carrying 3 gallons of water. It turns out on the International Space Station, if you have a gallon of water loose, it's really dangerous. Because there's no gravity, it can't drain away from an astronaut. If it gets on their face, they try to push it, the surface tension will just move the water straight back again. So you can drown in a gallon of water. So NASA threw the book at us for this. This was rated as the highest level of hazard classification. And we had to go through all the man rating standards for this. Now, as a startup company, we got funded. Our first check came in. We had a napkin sketch and an agreement with the International Space Station National Lab that they would help us to get to the space station. 4.5 months later, we handed over fully qualified flight hardware. Now, NASA had said this is going to take 18 to 24 months, right? The number of stories, the number of things that we had to do, but most importantly, we had to make sure that we hit every single requirement that NASA had in terms of safety. So incredible team of engineers that we pulled together, managed to get that done in 4.5 months. Both of those tankers then flew to the space station. Very successful mission. We learned some great things about the tech. It wouldn't be pushing the envelope and worth doing if we didn't make a couple of mistakes and learn from it, but we were able to pull off everything that we wanted there. So all of these things now have come together to allow us to launch the first operational fuel tanker. So we've now signed an agreement with spaceflight to fly on their Sherpa space tug vehicle. So we called this one Tenzing. Everyone may remember Norgay Tenzing as one of the first men to reach the summit of Everest. Of course, he carried bottles of oxygen and had many great things to say about going up and beyond and keeping your eyes on the heavens. And so we thought that was very appropriate to name this tanker after Tenzing. We look forward to announcing a lot more partnerships in the next few months around this, but we will have fuel available in orbit for those that wish to purchase it starting in 2022. So I probably have spoken far less time than what you'd allocate here, but I'm happy to take lots of questions.
Thank you very much, Daniel. That was terrific. I was telling my friend who's managing all the technology here. I've actually learned an awful lot from both yours and Nagar's presentation. And I tend to think I know what the heck's going on in this field, but every once in a while, actually all three of y'all, Rob earlier, there were surprises in each of your presentations. So I'm going to jump in and ask the thing that surprised me the most. I didn't know that you were doing inflatable fuel tanks. I don't know why that never occurred to me. I've been at this for a long time, but it didn't. So where did that come from?
We had the opportunity to fly with the International Space Station National Lab. We sat down and talked to them about the things that we were trying to do and our roadmap, and basically said, look, how much could we test? How far could we get with just one or two launches? And so we mapped that out. And there are a couple of things that we wanted to achieve. One was the basic propellant feed systems and basic technology that's going to be used across all of our tankers. The second one was, like I mentioned, refueling or resupplying the International Space Station, and just the mindset and knowledge of process that we gained from that. But then we also looked at some of the things that would really open people's minds to the possibilities, and that we expect to be big parts of a future ecosystem. And the inflatable tank was, it was an obvious one to us that we wanted to test and we wanted to fly, because there's a lot of difficult things in there. You can imagine you deploy this, what is a flexible bag, and then fill it with fluid. It has a very interesting dynamics to it,
right,
which will couple into your pointing control systems. So a lot of what we did actually was have the astronaut move that around and then stop it, just to make sure that our models were working and the slosh dynamics were modeled properly, so that we could build that into sort of the attitude control models and guidance navigation models that we have set up. So that was it was a really interesting part of that experiment. We got a lot of feedback on, frankly, applications for that we did not expect. And so that's been pretty exciting.
Wow, that's yeah. Are you? You're almost smirking when you said applications we didn't expect. Do you want to elaborate on that, or should I move on?
All right, guilty there. You may know my background. Most recently, before Orbit Fab, I was running Deep Space Industries, and actually 25 years of my career, I decided that in university that asteroid mining would be a good way to pay for the first permanent jobs off Earth. And so I would do that with my career. I'll be honest, I would very much enjoy if one day at Orbit Fab we've developed and implemented the supply chain for propellant, and we're able to buy materials from asteroid and moon mining companies, and then bring that material into the supply chain. We were contacted by a company that's looking to do lunar mining, who wanted to have a storage container for the water that they might extract on the moon. And it was actually that my experience in the mining industry that made me think of these inflatable tanks, because I'd seen fuel being stored at remote mining sites in inflatable tanks, much like this, where they ship the fuel in and fill the tank. And they're just effectively big, I'll call them canvas bags. It's an understatement. Yeah, it was great. A prospective lunar mining company reached out and said, we want the bags for exactly that application, which really made my month. It was great.
I bet it did. We've got some time. We've got a little over 20 minutes. Let me ask some questions here. Can more than one satellite dock at that gas station? So you showed that image with lots of modular systems. Yeah, right.
It's probably at the end of that video.
Yeah, that one. Right. So can you so the assumption is that lots, I guess I was under a false impression. I thought you were a flying gas can that came to your client. And what you're showing here is that you're a gas station, just like the corner gas station, and the client has to come to you. Is that like step one, step two, or am I misunderstanding something?
Yeah, our business is about providing fuel and propellant cost effectively. To do that, we can't afford to carry expensive equipment on our tankers. We make our tankers as low cost as possible. We make the fuel as low cost as possible. And we work very hard to be able to do that and pass the benefit on to our customers. That means if we're launching these tanks, then we want to stay away from the need to have them carry anything expensive, the rendezvous docking equipment and all the like. Meanwhile, our Beachhead Market is the satellite servicing companies who are already looking at doing the rendezvous and docking and carrying all that equipment. So while we've had to venture into that to understand what our interfaces should be and such things, it's not our intention at all to build satellite servicing vehicles and tow trucks. So we'll stay out of that business. We'll put the gas stations in your local suburb, so to speak.
Yeah.
We'll put them in convenient orbits. But then, it's up to our customers to come and get fuel.
I'm assuming low Earth orbit, geosynchronous orbit, MEO, but are you also thinking the Lagrange points and lunar services?
I'm thinking wherever there are customers. At the moment, those customers are predominantly low Earth orbit and geostationary orbit, but we're keeping an open mind. We've talked to a number of folks that would like to be refueled in lunar orbit. Or in different orbits that we hadn't thought about. For us, that's a trade-off between demand and the cost of deploying that infrastructure. As we see this market evolve at the moment, there's a catch-22. No one's buying because no one's selling. And we are solving that next year by launching that first operational tanker, which really says, look, there is inventory now in orbit. You can start building and relying on this. You can build this into your initially extended missions, later into your baseline mission. And so that's what we intend to do, is build that inventory out in advance. That means that we have to be selective about exactly where we put those.
You bring up a question I've had in my mind for a long time. Thanks. A question I've had in my mind for a long time is there's these proposals. I think there's one out of USC, I think, that's talking about exchanges, commodity exchanges for assets on orbit. Have you had any of those conversations? I mean, are we able to start trading pork bellies down here on the ground for orbital assets?
Well, at the moment we can't, but that's exactly one of the things that I expect will come to pass as soon as we have an inventory of propellant or any other commodities on orbit. I'm working with a group called Space Commodities Exchange. Right. You can look it up, spacecommoditiesexchange.com. They've had extensive discussions with regulators, the financial industry, Chicago Mercantile Exchange, where a lot of the commodities get traded, those types of folks, looking at how that might be established, as well as the US government and foreign governments that are also considering how this might be regulated and managed and used to promote commercial industry. So I think there's a lot of potential there. Space Commodities Exchange is not the only group that's looking at this, and there's probably many different approaches. So it'll be interesting to see how that evolves.
I'm not, this isn't my specialty, but I believe the exchange you're talking about is primarily European. And then the one that I'm talking about is primarily sponsored by the Defense Innovation Unit in the US. Is that correct, or am I wrong on something?
So the Space Commodities Exchange has an Australian CEO who lives in Frankfurt. The secretary is in Chicago, and the treasurer is in Chicago.
Okay. All right. Good. All right.
So,
Good. I don't know that ultimately it matters. I'm just wondering, as long as a service like that exists, you will tie into that kind of service.
Absolutely.
Yeah. One thing that we keep talking about over the for this lecture series, the last yesterday, today, and tomorrow, and then going forward for the next year, is really focusing on infrastructure, right? Infrastructure. And so y'all play a necessary role in that system, but we haven't really spent a lot of time on the financing component of this infrastructure. How relevant is that to your business model? Or do you not need it right now because, again, the market is still really small? I'm immature.
Yeah, I'll be completely honest. The technology that we're developing isn't that novel. Maybe you shouldn't tell my investors that, but
you had a good answer earlier about you'll go wherever the market is, so your investors are covered. We're good with that.
That's right. Now, at the end of the day, rendezvous and docking is solved. It's not productized, but you can get people who've done that before, and you can embark on a project and add rendezvous docking to your spacecraft. The fueling ports, and we've sold fueling ports on the ground. There's a couple of quirks in space, and we have to make that work. But it's not that technology that's our key advantage. The biggest challenge here is the business models. It's the fact that we have a chicken and egg that no one's buying because no one's selling, that I'm talking about building up inventory in orbit, and that's expensive. That's something our investors don't like, right? But it's something that has to happen. So we have had to think about a lot of creative ways to finance this business and bootstrap it. And we have to go fast on the tech, and we have to be extremely capital efficient. And then we have to work with our customers to understand how they perceive risk and be able to manage that risk, which comes not just from the technical side, but a lot of business considerations coming into that. Because if they make a decision to build their business that relies on supply of propellant in orbit, they've introduced risks into their business model. And so we work with our customers quite a lot on that, and we need to be quite innovative. And so we're bringing in different aspects of different business models from other industries that fit what we are doing and allow us to manage that risk appropriately.
How early do your customers or potential customers interact with you? I mean, you've got a custom docking system, you've got a custom, I'll say a software knowledge system for that docking. How early do the customers need to start working with you in order to de-risk their development?
We have found very strong interest because of the difference this can make to the business models of a lot of the satellite operators. And so we don't have an operational tanker in orbit yet, but we're still getting cold called from satellite operators that right. want to know if they can buy 1 or 2 years worth of fuel, which is great. I move it from CapEx to OpEx, right? That's the kind of right. business flexibility and advantage you get here. So we're having people call us. We're having the discussions about using the fueling ports. We're selling and shipping fueling ports. So we're already seeing that. How long is the delay between that turning into a fuel right. sale on orbit? That's a good question, and not one of the company secrets I'll share.
Okay, that's fair. That's fair. Do you say yes when somebody comes in and says, I want to buy a liter of water? Do you say yes, or do you have to say, wait and see?
The answer is yes.
Okay, good. All right. That's Absolutely. Good. I mean, is it just a question of negotiating long-term contracts?
There's a whole bunch of things that go into it. And of course, where do you want it? When do you want it? What quality spec do you want to meet? And this right. is This is a product that we need to spec carefully and make sure that we're getting them what they need, when they need it, where they need it, how they need it. And so as we are drafting all those sort of standard specifications for how we're delivering propellant, that's got to be done closely with our customers to make sure, and it's a startup, right? We need customer market fit, or product market fit rather. So yeah, we always having conversations. It has not moved to the point where it is a commodity yet.
You know, again, going back to the infrastructure component, I've heard probably 5 times since yesterday and today about standards, developing standards. We're in the wild, wild west. How easy or how hard is it to develop a standard, and how many customers have to agree to it for it to become a standard?
So there was a really interesting small satellite conference for those who are in the industry. You probably know SmallSat conference in Utah. About a decade ago, they ran with the theme standardization. And one of the best presentations that I saw was about why Ada is not a standard programming language. Ada is a very well-designed language, and the data seems to indicate that it is a lower life cycle cost to write and maintain code running Ada, especially for high reliability applications. But there is not a user community around Ada. I can't hire Ada programmers. I can't hire programmers and teach them Ada because they know that that's not a transferable skill. Nobody wants to work for a company that programs anything in Ada. So they all use C or C++ or Java.
Yep.
And these standards, if you look at those languages, they're not necessarily that great, but they work and they've been adopted and they solve people problems and they're accessible. And so when we think about standards, they will evolve because of those reasons, not because of being mandated on high by somebody.
Yep.
Once they've been brought into place, then the community picks up a pen and writes a standard around what's come into place. So what's more important for the industry is that we try a bunch of solutions and we figure out what does and doesn't work. And then once we've got a lot of operational experience, we can say, hey, what's the de facto standard? Now let's write that up. That's going to happen here. I don't think there's any other way to do it. I don't think there's any other way that we should do it because we haven't learned enough about how this industry has to operate yet.
I think what I'm hearing is flexibility is the key to this because we're so early into the field. Yeah.
Yeah, that's right.
How would you describe your company in terms of, if you're willing to share, how big is your company? What's your next step? You did raise some money. Are you raising more now? Where are you at? Just kind of like let us know, where your organization is.
Yeah, we're a couple of dozen people, so still fairly small. We have, we funded through flying that first operational tanker next year. That's going well. We have a lot of announcements coming out over the next few months. Things have been going very quickly this year, and I'll be honest, our marketing has not kept up with our progress. So keep an eye out for more things on that. Yeah, right now, let's see. We're hiring engineers, any great engineers on thermomechanical systems or electrical and avionics who are listening. Please check out our website. Yeah, very actively hiring. We just hired Adam Harris, who previously was leading the business development team at SpaceX, helped them win ELV and Commercial Crew. So we're very excited to have him on board. So we're getting the right people. We've got a phenomenal team. The engineering team have proven their chops, and what you'll see in the next few months is that the business development team are also really proven their chops. So I couldn't be more excited about what we're going to do in the next year.
Sure.
It's just a whole bunch that I can't say publicly yet.
Sure. It's a rare space company where their marketing lags their technology. Usually, we're all PowerPoint companies that have great slides, but our technology is not up to the hype. So it's a nice refreshing change to have your technology actually out in front of your marketing and sales.
I don't know how to do it any other way.
Yeah, there's so many amazing PowerPoint companies that never actually accomplish anything. So it's refreshing to see you guys actually building stuff and then talking about it. Tell me about your workforce development. We've had a big theme here about workforce as infrastructure. So you said a couple dozen people, you're growing. What are you looking for? What do you, and what I guess what I'm saying is, I don't want to flood your inbox with resumes, but are there holes? Are there gaps in your team? And not just your team, but like, what do you think for industry wide?
And from our team, I'm always looking to plug holes, and if I'm not haven't got any holes to plug, I'm trying to make some more holes. That's what expanding is about. So like I said, mechanical fluids thermo engineers, avionics, embedded systems engineers. That's our real need right now. We need both folks with 5-10 more years experience, as well as fresh outs. They're probably more right now on the experienced folks that we need. What's been really exciting, I'll be honest, when coronavirus hit and we saw a couple of companies struggling, we expected that it would make it easier to hire. That did not happen. Whenever there were a group of people who hit the market, they were gone within about 2 weeks. It was phenomenal. And so must be a great time to be an engineer in this industry, because you got your pick of where to go. And so in that way, we're also wanting to be very, very selective about who we bring in, very deliberate about the culture. We are radically transparent. We believe that for our customers, that is necessary. They need to trust us. But also it helps us to make sure that in the company we're getting things right. It just, as a CEO, is terrifying, because being a CEO is an exercise in making the mistakes that aren't the ones that kill the company. And so we are not perfect. So yeah, that's mildly terrifying, but is a real pillar of our culture. We're looking for people with deep knowledge, people who really can do things from first principles, because a lot of what we've done hasn't been done before. So we're looking for people who have a systems view, who understand how one tiny change in a spacecraft power system will affect the software and the business model and the revenue model all the way through the company, not just the technology. So we emphasize that a lot. Those are some of the things that we look for. And whilst there are very good people who have those cultural attributes and those skills in the industry, they're not in the majority. And so we are very picky. We're slow to hire, which means that almost always we have openings for great people like that.
I'm curious, as the company evolves, right? Where do you think you're going to be 2022, 2025, short term, but obviously you've accomplished something. So let's assume those accomplishments and then figure out what's next.
Yeah, the accomplishments that we will expect that we'll have in that time frame is a network of tankers in orbit and making deliveries to customers. So that's that mature ecosystem. Our long-term vision, though, is not just to be a distribution company, build the entire supply chain in orbit, and that means we'd like to go into chemical manufacturing and supply. So I would like to be providing propellant, lubricant, air, water, 3D printer feedstock, an entire petrochemicals company in orbit. That's what we intend to build.
You surprised me. I guess I've known you always had. I do know your background, of course, with DSI, but I've always known you had some pretty big ambitions. But I guess the stuff that I've seen about your company is really focused on the here and now of delivering gas. I guess you just a moment ago caught me off guard by saying you want to do the supply side also. That's a pretty big bite. That's biting off a lot. That's not soon, right? That's further down the road, correct?
That's right. That's our bigger vision for the company further downstream. But it's real. In the same way at Deep Space Industries, we hung out the shingle of being an asteroid mining company. We tried to build an asteroid prospector and failed. You'll see a theme here because we couldn't build thrusters. And so we became a thruster company. What we didn't do at Deep Space Industries was brand ourselves as a thruster and technology company. I decided at Orbit Fab that we were going to start with that branding of the technology company, the immediate solutions. And so propellant supply in orbit, what do you need to buy? It's hydrazine, it's xenon, it's green propellant, it's here, it's now. You need the technologies that will allow you to access that. That's what we're providing. It doesn't mean that we don't have a big vision that we're pursuing and making sure that everything strategically lines up with that.
Cool. We're running out of time. We've got just 2 minutes till we turn it over to Lila. Do you have any pithy words of advice from having been through the ringer with DSI and then taking that next step? It would have been easy to quit. I have, full disclosure, I had a space company that crumbled pretty dramatically. There are times when it's easy to quit. What brought you back? What made you decide this is what I'm doing?
So I think I've founded a dozen companies, maybe 14 now. 4 of them were serious startups. Orbit Fab is the 4th. So this isn't my first rodeo. This is my career. This is what I decided I would be attempting to accomplish with my life is to create the first permanent jobs in space through asteroid mining as that potential revenue stream and all of the steps that we need to get there. So I've had this big vision and I broke it down into realistic steps that I could get working on today. If you want to achieve something big, find out what is needed to be done today that will move the ball forward. That's worked for me so far. It's been extremely interesting. I keep learning every single day. Every single company is challenging. Yeah. This Orbit Fab is challenging, but the mistakes I'm making are completely new mistakes. So that's kind of good. At least not making the old ones. And so far, we seem to have done pretty well in terms of doing the things that we needed to do and getting those things right. So pretty happy about that. Perseverance and persistence is really a key to it, and having a long-term vision.
Terrific. Well, thank you. Those were pretty inspiring words. I really am grateful for you being here. We're going to turn it over to Lila, and thank you very much, Daniel. Really appreciate your time.
Thanks, Michael. Thank you, Lila. It's great to be on here.
Take care.
Thanks, Daniel.